Hello again, all you lucky people. Harbinger here again. And what I have for you this morning, early this morning, is what used to be once upon a time a Gator. This used to be a Gator amp. It's got a nice, really big, fat heatsink, which I really liked. Everything else, though, just sucked really loudly about this amp. And I don't mean loudly as far as RF goes. It had a transformer in it that was underrated with the voltage was too high, so they put a bunch of rectifiers in series to lower the voltage, which really killed the current. So it was you key down and it would just fall on its face, and it was just really bad. So anyway, so I redesigned it and turned it into this thing. It's using the HP 2500 SBs. They or were they 2500? Are they? Oh, 1200. I'm sorry. The HP DSP 1200s, and they're both just strapped together. They're not. Well, they're not strapped as far as load sharing, but they are strapped together on their outputs, and their outputs are matched. So that's something. But yeah, redesigned and rebuilt this thing. It has actually undergone a few revisions since I first put this thing together. One of the things I discovered were that these power supplies here were drawing current even while the little jumper down there on the bottom of the blades on these things was actually disconnected, which activates or deactivates the power supply. Even in a deactivated mode, they were drawing about 7 watts a piece. 7 to 10 watts a piece, which I found very irritating, and to say the least. So I put a contactor in there. I couldn't see this thing sucking power other than running that little LED to let you know there's AC there. I couldn't see it sucking power for no reason at all, so I put a contactor in there. One of the other things I did to this amp, of course, I put a big old pot on the front of it to control the input gain, since it seems to be rather have a rather high gain. And also, of course, put a big old fat meter in this thing. Yeah, the face on this thing is completely different. It has this nice black textured steel face, or plate, if you will, and got some nice little LEDs for it and all that fun stuff. I forgot to mention the sideband circuit. Unlike your typical sideband circuits, they just ground the capacitor to delay the circuit. This one actually, when it's an AM, it grounds all the biases. Besides them being pretty well strapped to ground with the resistor, they're all these are not only have diodes, but they also have 1.5 ohm resistors or 1.6 ohm resistors holding their bases to ground potential. So this amplifier utilizes the C's, and I was having some problems with them, being they really don't like the typical bias that your typical 2879s are able to take. So I had to mount a small buck converter in there, and it basically helps knock that voltage down even further, down to 1.8. So 1.5 is just a little bit too high. I was actually had some problems with that, or I should say the finals were having some problems with that. One of the things that I've done, you probably noticed, is that these capacitors that sit on top of your transformer here, I don't bend them and I don't solder them the way people usually do. I noted a lot of people would solder them onto the front, and I discovered that for some reason it was causing attenuation. It was interfering with, it was getting some kind of interference, and so I found out by bending the leads a little bit and then soldering them on the top of the board, they don't have any negative effect on the efficiency or the output. The other thing is that, as you notice, this side, I did bend it, but it's a single, if I could get this camera to behave, it's a single plate. Over here on this other side, there are numerous plates, but what I've done is I've only bent the bottom plate, and the rest of them I just clip off and then solder all together, and of course solder them to the bottom plate, and that way when I mount these things the value doesn't change. It remains constant as when I tested it. It'll still hold its value when they get soldered on. Bending these plates causes them to offset under their compression, and so they don't have the same voltage or the same value after you bend all these multi-plates, and then of course the top plate winds up being pulled out further than the bottom one, and so you have an offset. It's like offsetting a deck of cards. So yeah, so that's something to note. The other thing with this, if you noticed, the combiner is really tight in there. It's really kind of hard to get to, but I like the typical conventional winding. Well, I use solid, of course, solid conductor, solid copper, electromagnetic. The bias resistors, only two of them actually utilize the buck converter. Those two being the output 2879s. The 2290, the driver, it gets full. It gets the full current from the 25 ohm resistor. and boy, does this thing kick. For just four pills and 13.8 volts, this thing really kicks hard. I use the clads in here, being that the person I built this for wanted all clads on the output, so that's what I utilized, except for these little 3 kV 100 picofarad caps. I forget what they're called. They're like a clamping type capacitor. But of course, I utilized BBI's method of feeding the collectors, not through the transformers, but giving them their own power. This amplifier, it when I first put it together, of course I thought, well, it's going to be perfect, it's going to work fine, it's not going to have any problems. But it was plagued with problems instantly, and the reason being was that not all these combiners are equal. These transformers, these ferrites are equal. The person I was building this for bought some transformers from somebody on the internet. They stand quite a bit higher, anyway, he thought he was getting number 61s, but they weren't. One stack, both stacks on one of them read correct, and the other one on the other stack were giving me almost an entire Henry of a microhenry, excuse me, giving me well, actually more than a microhenry of difference, and that was just from one stack to the other, checking them, against one another. Not to mention just checking them against the cross. So anyway, what was happening is when this amplifier would key down, they would after it would get unkeyed, the oscillation between the two sides would become so great that it would not only fry the resistor and the combiner in the back, of course, because you got a mismatched amount of power, but it would take out the damn finals too. Extremely, well, damage them extremely, so that it couldn't be utilized. It would create a bunch of noise and or would just continue to oscillate. So anyway, yeah, it it took a while to discover what the problem was, being that everything was matched. I use an LCR and make sure I matched all the resistors, all the capacitors, every single component in here has been matched by LCR, right down to to as far as I could go beyond the decimal point. I just put it that way. This amplifier does not act like a typical 4-pill amplifier, especially the HG 2879Cs. This amplifier, because I utilized a certain type of design, which in this big deep dark tube in here, as you know, there's no coil from the output. That's this big old 400 coax coming out, going through this capacitor and coming over here to the transmit relay. The reason being is that the coil exists on the inside. It's a 2.5 or 3 turn coil. It extends almost all the way to the end, and it sits inside 3/4 inch PEX, or basically your PTFE, your your Teflon So it's utilizing a Teflon piece of PEX tubing, and I don't think I'll get a light in there, but you can almost see there's a coil in there. If I could get the camera to go in the direction that I want it to. Yeah, there it is. You see there's a coil in there. Well, sort of, kind of. But anyway, yeah, I don't know. I got the design. I checked it out with ChatGPT. I believe that's what I utilized. And at first I was using PVC, but this is on a different amp. I discovered this. But first I used PVC, and the ChatGPT recommended using Teflon. So I went ahead and took its advice and utilized a number 8 turn number 8 wire and make a coil to fit inside that Teflon is pretty tricky. You'll be making some faces if you try it, but I guarantee you the results are fantastic. The reason being, I hypothesize. I'm not an engineer. I don't have a degree. And even if I did have one, I wouldn't use it, except for information. But yeah, I hypothesize that the reason why this particular design provides more power is that the coil, acting as the trap, Pi-L network as it is, or basically a low-pass filter, being it's shielded, it's not radiating RF out. It's actually channeling that RF and forcing it to actually go out the transmission line, as opposed to radiating on a coil, here in the open air like most amplifiers have. So I think that's what's the reason why it kicks so hard. I was pretty surprised. I'll go ahead and turn this knob all the way up, and I have my little diamond meter here, and it's set on the 3,000 watt scale. If I could get this thing to excuse me, actually look at it. And it's not quite behaving, huh? I'd help if I didn't have all this stuff in the way. But I got a little 979 here, Galaxy. It's on AM right now, and I got the power about there. And let's see what she does. Let's see here. I got a cheapy, some old broken down, I think it was a Cobra mic once upon a time, but I made it rechargeable because I didn't like those little batteries that were in it, those little cell batteries. So I put a lithium rechargeable in there and a port, and let's see what it does. Let's see if it even works. All right, we are on average, because I don't peak power. Peak envelope is kind of a lie. I rather just stick with the average, or RMS if you will, root mean square. Anyway, let's see what we got. Oh wow, that's a lot. Did I turn this thing down a little? Let's see here. Ooh, oh yeah, that's about 100, and it swings. Yeah, wow. It swings to 1,000, and it jumps up to about it jumped up to what, about 1,200, huh? So and that's on average. Now if I go peak, it's just gonna make your make my head swell and anyway, yeah, let's see what it looks like. Oh, it's squealing. I got too much mic gain here. Yeah, it doesn't like this power mic. Let me turn the mic gain down a little. There we go. Now let's see what we got. Wow. Wow. Bow wow. Well, I don't know if you could believe that, but according to that thing, we got 1500 watts peak out of supposedly 4 finals that are rated at 150 watts peak. So something's wrong with the math here, or something's interesting about this design. I haven't figured out which. Anyway, yeah, the little meter here on the front really doesn't do anything but just tell you that it's working. Yeah, it's working. Oh yeah. Oh boy. Yeah. So anyway, I was naming this amplifier the Legacy, but it wound up, since it wound up having require so many revisions and so many repairs, it had so many bugs and so many problems, I renamed it the X. And since I really didn't expect it to put out any more than 800, and that's what it was putting out at first, I called it the X800. But since it's working quite nicely now, one of the other things I discovered are these power supplies. They may not mention it anywhere, but they put out a lot of noise, and I had to stick a big old ferrite piece of ferrite in here to filter out the noise, because every time I flip this switch to operate, I would get a bunch of noise on my receive on the noise floor. So that was unacceptable, and of course I had to stick a bead over here because these power supplies put out noise. The people might say, oh, they're really clean and this and that. Well, yeah, they're probably really clean on transmit, but on receive, they need a few things. They need a few pieces of ferrite material. Anyway, it took me a while, like I say, to build this amp and get it all working the way it's supposed to. It's got a remote plug on the back where it could be keyed down. There's a little plug way down in there, so it could be keyed down. And looking at the back of this thing, whoa, almost dropped the battery in there. It's got some vent holes. I had to make this entire area longer and make them a little bit less obtrusive. I was thinking with these amplifiers, a lot of people want to put voltage meters on the front. I think it would actually be more practical if if they went over there and put in not a voltage meter but a temperature meter. The last amplifier I built, the big old 2.5 kW, that thing was a beautiful amp. Well, it still is, but it got overheated, and being it got overheated, the finals are now bleeding, and it makes a bunch of noise onto the receive. So I did replace a couple of them. I was lucky I had a couple 23s left over. 23 DO8s. I have no idea why I had them, but yeah. So I put those in there, and and it worked for that one. But this one, these are all new. These are all new finals. This is actually the third set. That's how bad, that's how horrible those bad combiners, those bad transformers screwed me up. So I had to eat that cost, and I really didn't appreciate that. And the person that makes those little high-rise transformers, you know who you are. The same person I was telling, I sent a message to regarding these power supplies, how they really require a contactor, because the damn things just eat up power while they're sitting there not doing anything when they're supposed to be off. But too much pride. People have too much pride. They're not humble, so they'll never admit that they were wrong or at fault, or say thank you. I mean, that's all really I would have liked, but oh well. To each their own. Everybody's got something stuck up their craw somewhere, I guess. Anyway. Oh, okay, there's one more thing I forgot to show you all, and that was sideband. So let's look at the sideband, and let me show you what she does on upper sideband, which is put my power meter back on average, so that way I'm not lying to everybody. If I can get this thing to focus, I'll be happy. Focus, focus, focus. There we go. Kind of, sort of. Alright. This is what she does on sideband. Audio, audio, woo, woo. Click. Yep, nice 1.5 second delay, I think it was. Yep. And hey, why don't we see what that is on? Looks like on peak. All right, here's peak. Oh boy, oh boy. Wow, almost no difference. Almost no difference. Okay. Anyway, that's all. That's all we have. I hope that any questions or anything in regards to an amplifier like this, building something like this. I like to say I'm your guy, but I'm not really not. I'm not a shop. I do this as a hobby, and I do it as a favor to some people. I got too many other things I need to work on as far as getting acknowledgement of an animal that I'm dealing with. If you've seen any of my other videos, you'll probably understand what I'm talking about. An animal named Junior. So I need to take care of Junior first before I start thinking about customizing, building any more damn amplifiers. Anyway, like I said, I'm not a shop. That's the extent of my inventory right here. Really don't have a whole lot. I have a few good books. My Bibles. Those are those are all my Bibles. Electrical engineers books and handbooks and all that fun stuff. But other than that, most of the information I find is on the net. But this thing right here is something I haven't seen anybody do. Putting the trap inside the trombone capacitor. And I have been very pleased with the results. It's been an unbelievable it's been quite an unbelievable treat to see how much efficiency I'm getting out of this thing. So anyway, y'all have a good one out there, and we'll see you all around the ranch if possible, if I'm still kicking, if my brain is still having synapses or synapses, however you want to look at it. Anyway, you take care of yourselves out there, take care of each other, and yeah, this is me, and we'll see you around. Have a good one. So where is the off button? All right, bye.